Korea is one of the world's leading nations in the development of nuclear power plants. Korean nuclear power plants are unrivaled and have been a solid foundation in making Korea a prominent country. Korean nuclear technology is acknowledged by the global community. In particular, Korea distinguished itself in the development of pressurized water reactors and successfully exported nuclear power plants to the UAE. In addition, Korea initiated the design certification with the United States and Europe. Now, our country is showing elite status as a leader of nuclear technology. Following the OPR 1000 and APR 1400, the APR Plus is a newly designed nuclear power plant with enhanced modifications to improve safety and economic feasibility. With the 1500 megawatt class advanced reactor, the status of Korea's global competitiveness has soared in the international market. The APR Plus is a safety-enhanced 3+ generation PWR nuclear power plant with a large capacity of 1500 megawatt class. Hyper 16 is a highly efficient nuclear fuel with modifications in thermal and earthquake-resistant characteristics, enabling the sufficient safety margins. And the design life of the nuclear reactor is extended to over 60 years, as its reactor is made with highly resistant material, which prevents irradiation embrittlement. Steam generator tubes are made of alloy 690 material, which is used to decrease pipe wear and corrosion. And the shutdown sealing design is used to prevent leakage in reactor coolant pumps. The APR Plus has been designed with a load-following operation, which adjusts the generator output so the amount of electric power generated and consumed would coincide. Thus, automatic control is possible for electricity generation and axial power distribution, which are necessary for output increase and decrease. This reduces the burden of manual operation and improves the overall operating capabilities. The safety systems are designed with 4 trains. Thus, emergency situations are handled more effectively, as 1 out of 4 systems in operation is enough to mitigate an accident and safely shut down the reactor. Furthermore, in case of emergency, a guide duct for safety injection has been set up in the flow path within the reactor, and the guide duct has been designed to cut down on the bypass loss ratio of emergency core cooling water injection, which is required to cool down the reactors. Emergency diesel generators power electric power to the 4-train safety system independently during the loss of off-site power. When the diesel generators are not in operation, power can be supplied by gas turbine-type alternate AC generators. In addition, safety-grade batteries are used as the last emergency electric power, and they last for over 72 hours. The passive auxiliary feedwater system is developed and applied for the first time in the world and is operated using a gravity and condensation principle without additional supporting equipment. This system can cool down the reactor in 8 hours and can maintain the safe cooling status for over 72 hours without electric supply. Moreover, the safety function of this system can be maintained as long as additional coolant supply is available. External accidents and natural disasters occur without any warning. The APR Plus has a strong, resilient design that can withstand these unforeseen severe situations. Seismic designs have been implemented so that the facility can uphold its safety functions in the event of an earthquake of 0.3 G. The outer walls of safety-related buildings, including the reactor building and the auxiliary buildings, are reinforced to withstand the impact of a large commercial aircraft. The main control room, as well as the remote shutdown room and other major components, are located in safe places to protect them from aircraft impact. If severe accidents like core meltdowns occur, the external reactor cavity is designed to fill up rapidly with coolants to cool down the corium in the reactor without external release. The cavity flooding area located on the bottom of the reactor containment building is designed so that corium can spread and be cooled down if it escapes out of the reactor. The emergency reactor depressurization system swiftly lowers the pressure so that the high-pressure melt ejection will not be released. The emergency containment spray backup system quickly cools down steam to prevent overpressure in the containment. Passive autocatalytic hydrogen recombiners are placed throughout the reactor containment to prevent hydrogen explosion. All of these system installations reinforce the safety of the APR+. The buildings are arranged in consideration of the safety function and ease of operation. The reactor containment building is located at the center of the nuclear island. The auxiliary building is located around the reactor building, and the compound building and turbine building are located at the side of the auxiliary building. Based on a vast experience of nuclear reactor construction, steel plate concrete structure, reactor vessel internals modules, over-the-top method, and other advanced construction methods will be used to build the APR+. The 4D simulation tool, reflecting APR+ integrated project schedule, enables the verification of the interference during the construction processes. The overall construction project is therefore established, providing a more systematic construction approach and effective management oversight. APR+ is a nuclear technology that is cost-efficient and smart. It will be a driving force in the international nuclear power plant market. Korea's nuclear energy APR+ is a technology which places top priority on people and the environment.